Today, we're diving into a revolutionary idea that could alter the course of space exploration as we know it. Have you ever thought about living not just outside Earth, but on one of its most mysterious moons? Yes, we're talking about Titan, the fascinating moon of Saturn. But why Titan, and not Mars, which has been the focus of so many of our space ambitions so far? Colonizing Titan instead of Mars could offer some distinct advantages, depending on the goals and priorities of space exploration and colonization. Today, we'll explore some reasons why Titan might be considered a more attractive option than Mars for future colonization missions. Radiation protection is a critical factor in choosing destinations for space colonization, due to the severe health risks that cosmic and solar radiation pose. Titan, the largest moon of Saturn, stands out as a promising candidate for future colonies due to its dense, nitrogen-rich atmosphere. This thick atmosphere provides substantial protection against radiation, dampening energetic particles and significantly reducing the risk of exposure. This contrasts sharply with Mars, whose thin atmosphere composed mainly of carbon dioxide provides very little barrier against dangerous radiation. Colonists on Titan would benefit from reduced risk of DNA damage, cancer, and other health issues related to radiation, a persistent challenge on Mars, where habitable structures would need special shielding or to be underground to offer similar protection. Additionally, during solar storms, which emit large quantities of energetic particles, Titan's atmosphere could provide critical defense, protecting both humans and vital electronic systems necessary for the survival and operation of the colony. Titan's capacity to offer natural radiation protection puts it in a favorable position as a potentially safer and more viable location for expanding human presence in the solar system. Titan stands out due to its rich abundance of liquid hydrocarbons like methane and ethane. These compounds, which form vast seas and lakes on Titan's surface, present a unique opportunity for energy production and manufacturing essential materials, providing a basis for a self-sustaining extraterrestrial economy. Utilizing hydrocarbons on Titan could be a viable solution to the challenge of generating energy in such a remote environment with limited access to sunlight. In contrast, solar energy on Mars, despite being more feasible than on Titan due to its proximity to the Sun, still faces challenges during frequent and extensive dust storms, which can block sunlight for weeks. Additionally, Mars requires drilling into frozen ground to access water, a crucial resource for sustaining human life and for fuel production. On Titan, hydrocarbons are accessible in liquid form on the surface, potentially reducing the technological complexity and associated costs of their extraction and refinement. Besides energy, Titan's hydrocarbons could be transformed into a wide range of useful materials, from plastics to potential synthetic fibers, helping to build and maintain colony infrastructures. This ability to locally generate a variety of essential products is a huge benefit, especially when compared to Mars, where resources are more limited, and their exploration and processing might be more challenging due to the arid environment and extreme atmospheric conditions. Therefore, while Mars offers advantages in terms of proximity and geological studies, Titan could stand out as an industrial production hub in the solar system, with a capacity for sustainability and self-sufficiency possibly superior. Titan's gravity, which is about 14% of Earth's, presents several notable implications for the exploration and potential colonization of this moon of Saturn. This low gravity is comparable to that of the moon and brings significant advantages, especially in terms of space logistics. Landing and takeoff operations become more efficient and less costly in terms of fuel and energy, since the force needed to escape Titan's gravity is substantially lower. This not only reduces the complexity of missions, but also allows for the design of lighter spacecraft and the planning of return missions or interplanetary travels with much higher energy efficiency. From the perspective of habitability and human health, Titan's low gravity also offers a unique setting for research and adaptation. While the long-term effects of low gravity on human body systems, such as bone density and muscle mass, are a known concern in prolonged space missions, Titan's environment allows greater ease in movement and construction. This can be especially useful in assembling infrastructures and handling heavy materials, reducing physical effort, and potentially increasing the efficiency of colonial activities. However, adaptive technologies and ongoing studies will be necessary to ensure that colonists can live healthily under such conditions. Furthermore, Titan's low gravity provides an ideal stage for scientific experiments that would be difficult to conduct in higher gravities. Research in physics, materials, and other fundamental sciences could greatly benefit from these conditions. Additionally, Titan could serve as a strategic base for launching deeper missions into the outer solar system, exploring its potential as a transit point for further explorations. With these factors in mind, Titan not only stands out as a fascinating destination for future colonization missions, but also as a potential center for scientific and technological advances in the low-gravity environment. The extreme challenges of colonizing an environment like Titan could drive advances in technology, especially in areas such as robotics, life support systems, and energy technologies. This could have beneficial applications on Earth as well. As we look to Titan as the next major step in human expansion across the solar system, it's crucial to consider the logistical and technical aspects of this ambitious journey. Despite the positives, Titan presents a significant challenge in terms of space travel. Depending on the orbital positions of the planets and the propulsion technology used, the journey to Titan could take from 6 to over 7 years with current technologies. This extensive travel time implies not only significant advances in life support and propulsion systems, but also the need for robust psychological and physical preparation for the astronauts who will make this journey. The trip to Titan would not be a simple orbital transfer, but an interplanetary expedition requiring innovative solutions in areas like resource recycling, radiation protection, and maintaining human health under prolonged microgravity conditions. Furthermore, the arrival and subsequent colonization of Titan would offer unprecedented potential for scientific and technological advancement. The ability to directly explore Titan's hydrocarbon seas and study its complex atmospheric chemistry could provide crucial insights into prebiotic chemistry and possible life forms based on solvents alternative to water. These discoveries could not only expand our knowledge of life in the universe, but also drive new technologies that could benefit Earth. These features make Titan an intriguing and potentially more advantageous choice for future colonization missions. Of course, the challenges are immense, and the necessary technology is still in development. But imagining the possibilities can inspire us to continue exploring and innovating. Don't forget to like, subscribe to the channel, and hit the notification bell so you don't miss our next videos. Comment below what you think about colonizing Titan and what other topics you'd like to see here. If you dream of seeing humanity reach new horizons in the universe, don't miss our previous video, where we explore the huge challenges of a landing mission on Saturn. Now, I invite you to dive even deeper into this space adventure. Until next time.